Okay, welcome to Mac 132 Blueprint reading, the last class before our test. What did we learn today? Well, we reviewed GD&T 1, 2, 3, the basics of GD&T. GD&T 1, 2, 3 refers to establish the datums, then control the datums on the part, and then locate the rest of your features to the datums. The 3, 2, 1 rule of GD&T is that you must have 3 points of contact on the primary datum, 2 points of contact on the secondary datum, and 1 point of contact on the tertiary datum. So that if we have set up our machine, our milling machine properly, then we will have a flat surface to set our part down. Like if it was on parallels, that'd be tied to datum A here on the bottom. Datum B would be the vice jaw stationary in the back, at least 2 points of contact there. And the last thing would be the part stop for the third for datum C. Now the part is going to be completely restricted in all 6 degrees of freedom, and what's nice about that is that they both relate to each other in GD&T terms back to the datums. You understand datums at a very deep level, then you have a very big head start on GD&T. The next thing I did was I went over tolerances of form. There are 5 tolerance categories. They're over there on the board: form, orientation, location, runout, and profile. We will get more into the details of these as we after the test. But today, what I talked about was tolerances of form and also a position and location. I had 2 holes drilled through a part. This one was drilled straight. This one was drilled at a 1 degree angle by mistake, because the machinist did not sweep the table on the milling machine before he went to work. So the basic dimensions here are locating the tolerance zone. They're not locating the hole, they're locating the tolerance zone. So they're theoretically perfect dimensions that to the center of this hole, but what they refer to is when you see a basic dimension, you start looking for a tolerance zone. All right, here is the feature control frame that is connected to the tolerance zone. And the tolerance, it's important to say, is applied to features and not to dimensions. That's why they're called basic dimensions, I believe. Now, the true position of this hole was supposed to be within a diameter of 10 thousandths all the way through the part, so that it would be relative to datums A, B, and C. This one was drawn correctly, and so the hole is a 1/2 inch, and it is at its right size. This hole was drilled at a 1 degree angle, and now our 1/2 inch hole is smaller, and it is no longer perpendicular. So I pulled this together to show you how you get 2 for 1 sometimes. If you have true position and you have established your datums, you get perpendicularity. If over here, if you have flatness, then you also have straightness. And I showed you if they only called for straightness here, then we could have a bowed line or a divot behind that line, and the part would still be good because the engineers just said this line here had to be straight within 10 thousandths. This is the GD&T standard, and those are the 5 categories of the thing we talked about: maximum material condition, least material condition, and rule number 1. You should have all those things kind of memorized by now. We showed that on the model that the datums of matching parts must be in common so that they will fit together, and if they aren't in common, then they may not go together because the datums and dimensions were drawn from the different surfaces. All right. After we take the test, we've got to be ready to do homework on pages. I handed out, I told you what pages the homework is going to be on. It's like 303 and, yes, it was 303 and 305. We're going to get big time into the other GD&T tolerances categories after that, and we'll have a test in another 2 weeks. Thank you. Have a good day.